Hello everyone, I am Ankit Saha. Today I am going to present a presentation on the topic Frequency Compressive Feedback Demodulator. Let us introduce you to this topic. The application of frequency compressive feedback around an amplitude insensitive FM demodulator promises important reductions of distortion and noise sensitivity in the demodulation of wideband FM signals. In this paper, the basic theory of FM demodulation with frequency compressive feedback (FCF) is presented after a brief discussion of the concept of noise threshold and of the usefulness of threshold reduction techniques in relaxing important requirements in the design of reliable communication systems. Let us go to the next slide. Let us take a look at the block diagram. In the block diagram, we can see that the input we are receiving from the radio IF stages, which goes to the phase detector, and the phase detector detects the phases and sends it to the loop filter. The filter strikes off all the ripples and sends forward the wanted waveforms. Between the phase and the output waveform, there is a VCO which amplifies all the. Now let us move to the next slide. Let us see the performance of FM demodulator. The PLL FM demodulator is normally considered a relatively high performance form of FM demodulator or detector. Accordingly, they are used in many applications. The PLL FM demodulator has a number of key advantages, like linearity. The linearity of the PLL FM demodulator is governed by the voltage to frequency characteristic of the VCO within the PLL, as the frequency deviation of the incoming signal normally only swings over a small portion of the PLL bandwidth. Now let us take a look at the manufacturing cost. The PLL FM demodulator lends itself to integrated circuit technology. Only a few external components are required, and in some instances it may not be necessary to use an inductor as part of the resonance circuit for the VCO. This fact makes the PLL FM demodulator particularly attractive for modern applications. Now let's go to the next slide. In the next slide we'll see the FM slope detection basics. Here in this graph, on the x-axis we have the frequency, and on the y-axis we have the impedance, and there is a curve. The lower part of the curve gives the lower frequency, the center part gives the carrier frequency, and the upper part gives the upper frequency. We can obtain the maximum output from the upper frequency and the intermediate output from the carrier frequency, and the lower frequency will give the minimum output. Let's move to the next slide. Let's take a look at a few questions related to this topic. First question, automatic level control ALC is used to keep the modulation index close to 100%. ALC stands for automatic level control. It is a technology used for automatic control of output power. The next question, transmitters are designed usually to derive a load impedance. The answer for this question is transmitter is an electronic device that produces radio waves with an antenna. The transmitter itself generates a radio frequency alternating current which is applied to the antenna. Transmitters are usually designed to derive a load impedance of 50 ohms resistive. The third question, what we call the resistor if a transmitter is connected to a resistor instead of an antenna? Answer will be, if a transmitter is connected to resistor not antenna, then it is a dummy load. Now in the last slide, I'd like to conclude the topic by saying that PLL FM demodulator is one of the more widely used FM demodulator or detector these days. Its suitability for being combined into an integrated circuit and the small number of external components makes PLL FM demodulation ICs an ideal candidate for many circuits these days.